myself in the right view here. Awesome. And actually, I'm going to get into PowerPoint instead of Zoom. All right. There we go. All right. Welcome, everyone. Thank you for joining us. Thank Kevin and Drew for having me tonight. This is fun. This is actually, because of the pandemic, I really haven't been speaking as much this year, which is really weird because last year I spoke at I did 40 presentations at 23 events. And this year I didn't do any events from end of February till like 2 weeks ago. But I've really been looking forward to do this talk. I've been playing with Cosmos for probably the last 5 or 6 years. And, it really, it's not the solution to everything, but it is a really nice solution, especially when you need NoSQL databases at a global scale. And that's kind of where I've used it at several different places. So, and this will be my most prepared statement I have here. So, David Bowie might not be able to trace how time changes him, but the Azure Cosmos DB change feed allows us to trace the changes your data within the Cosmos database. The change feed listens to the Azure Cosmos containers for any changes and then outputs in the sorted list of documents that were changed. In this session, we're going to learn, what exactly is a change feed, how it works, and how you can actually use it to build more robust applications. So as Kevin said, my name's Chad Green. At least for a couple more days, I am Director of Software Development at a company called ScholarRx. Here's all my contact information. Definitely feel free to reach out to me at any point if you have questions afterwards. And then, just a little self-promotion, I do stream at Taylor & Code on Monday, Wednesday, Friday at 8 p.m. Eastern. And sure enough, I'm doing a lot on Cosmos right now. Actually, I'm actually preparing for the next talk about Cosmos I'll be doing in next month. So, all right. So sure enough, let's rock this thing out and make things happen. All right. All right. So let's start with let's talk real quick because probably there's folks out here who don't know what the change feed or what Cosmos is. Let's just go quickly through that. In simple terms, globally distributed, massively scalable, multi-model database service, right? That's the the little tagline that they use. And it actually does a good job of describing it. But go in a little bit more detail. What do we mean by this? Well, number one is the fact that it's a turnkey global distribution. And literally with a click of a button, I can have data, go from one location of the data to 5 other locations, right? And it's so easy to do this. And the fact that Azure is all over the world. I forgot how many data centers are right now. I think if they're not at 60, they're really darn close to 60 at this point. So your data can be all over the world, which means your data can be closer to your users. We can have, so you can reduce that latency that people have to wait for their data. And this becomes more important than you think about, all right? So for example, where I'm at right now, we have users all over the world. It's medical students all over. And right now we have folks from India trying to go all the way to the United States to get their data, right? And every once in a while we see timeouts, right? And even as fast as Azure is, now granted we're not using Cosmos for this, but even as fast as that is, you see that latency, and the biggest reason is just how long it takes to go across the world. This is one of the great things you get with Cosmos, and the fact that it's a click of a button and it's multi-write. Right, so I can write data. I can have data written in Virginia. I can have data written in California. I can have written in India, and it all syncs up together. And let me tell you what: try to write your own data synchronization. I have done it, and I never, ever, ever want to do that again. Right, that's one of the things I've learned in my almost 30 years of software development is I never want to do that again. Right, but Microsoft has done a really good job of that. Our next thing is the elastic scale out of storage and throughput. And basically, you can't run out of storage, right? Because basically they can just keep on handling more and more storage. I'm sure there's some theoretical limits, but as far as what you can purchase, you can keep on buying whatever you need. And sure enough, storage is it's a quarter of a gigabyte, so not that bad of a price. But there is actually a little bit more consideration there. And scale out of throughput. And this is, well, sure enough, when people talk about the cost of Azure, this is really what they're talking about, because this is where things cost money, right? But I can continue to scale out, and I can scale back down and so forth, especially now. And I forgot the name of the feature, but basically I have an auto scale feature. So, if let's say normally you need, say, 600 RUs, 600 request units. That's what you're paying, that's the unit that you pay for the throughput. But, maybe once a week for a 30-minute time span, all of a sudden you get a massive rush of data, right? Well, with this auto scale, I can have it scale up and say, normally it's say 600, but then, it'll scale up to say 4,000, right? And of course, these are, when we talk about a request unit, basically, 1 RU is equivalent to a 1K write. And that's the easiest way of thinking about it. I'm sorry, not a write, a 1K read. And then generally, a write is 5, a 1K write is 5 RUs. But, that's how you can kind of think about it. There's a little bit more into it, but that's the general way of how that works. Next is the fact that we have guaranteed low latency at the 99th percentile. And what do I mean by low latency? You're actually guaranteed for both reads and writes at 10 milliseconds at that 99th percentile, which means basically you're going to get 10 milliseconds or less. Actually, it is less than 10 milliseconds is the guarantee. And that is super fast. And sure enough, in my experience, I normally see my reads around I've actually seen as fast as 3 milliseconds, but usually 4 to 7 milliseconds, depending on what I'm getting and the structure of the data. And my writes are usually in the 5 to 8 milliseconds is what I normally see. But, these are incredible speeds. And the even better part is, one of the things that Cosmos does, by default, it actually indexes everything in your database. Every column, every document, every property, let me rephrase it, every document and every property within that document is indexed. And think about this, right? And they're still guaranteeing 10 millisecond reads and writes. Right? That's amazing. Next is the consistency models. And and here's the thing. So when I first was looking at a NoSQL database, this was 5 or 6 years ago, and basically we had a consultant say, and by consultant I mean a buddy of the president of the company who who knew better than everybody else, and they were like, oh, you need to get away from SQL Server. You need in SQL you need to get to a NoSQL database. And of course, my first thought was, NoSQL databases, and again, some of this was limited knowledge, but it's this eventual consistency. And I'm like, no, I grew up on ACID transactions. I know when that transaction happens that it's consistent across all my nodes. Well, Cosmos actually, they thought about this, or I should say Microsoft thought about this. And so they actually built in, these 5 different consistency models. So sure enough, you have eventual, right? And on the complete opposite end, you have strong. So, on strong, basically it's, for a fact that when it's written, all the nodes are consistent, right? So for a fact I can go to another node and get that same data, right? Along in the middle, they have bounded staleness. So the idea here is I could say, I want to make sure that within, say, 20 seconds or 5 reads, and you actually, or 5 writes, I should say, and you actually do specify those 2 values. I want to make sure it's consistent, right? So that way, a little bit of eventual, but also saying that I want to make sure that it's going to be consistent within this amount of time. In the middle, and what's the default is session, and this one makes the most sense for most applications, because this is saying within a session it's consistent, and really that's generally what we want for most applications. And then right before you get to eventual, they have the consistent prefix, and basically the way how to think about this is that it's eventual, because eventually it's going to be consistent, but at least what is that it is going to be in order, right? So eventual consistency, I could write ABC and it might actually be committed as ACB or CAB or what have you, right? With that consistent prefix, I'm actually guaranteed. I might not get ABC right away, but I'm definitely going to get A, or I'm going to get AB, or I'm going to get ABC, right? I'm never getting them out of order. So that's a great way of knowing my data is being read back in the same order it was written. All right, next are the SLAs. So, so now, grant you, SLAs are only as good as the paper written on in some sense. But I mean, you do get 5 nines of availability, that's guaranteed. And here's the thing about Cosmos, or I should say about Azure in itself. A couple months ago, we had media services go down. Now, media services itself didn't go down, but it did for us, right? I mean, we had an isolated issue, and it wasn't our fault. It was something on Azure side, and and sure enough, working with the support team, it was down for, I want to say 6 or 7 hours, and sure enough, one of the things that we do a lot at our company is videos, right? So people are watching videos to help them learn. And so obviously those videos are really important. And, I remember talking to my infrastructure guy when we were submitting the claim, and like, yeah, we're probably gonna get like $20, right? Or something real small, because I mean, media service isn't that expensive, right? We actually got like $400 in credits, right? So the credit, they really do take their SLA serious, right? And so you at least have that guarantee that they're going to do what they can to make sure that they're not paying out those fees. All right. Next, the thing about Cosmos is it is truly battle tested, right? So you don't really have to worry about this. And part of the reason why I say it's battle tested is because of how it was built. So Cosmos actually wasn't built to be a product to sell, right? They actually built it internally. And they built it for Xbox Live, for 365, for Skype, and for Azure itself, right? And so sure enough, one of the questions I'll hear a lot when I talk about Cosmos is, well, what happens if Cosmos goes down? Well, you're going to have bigger problems because Azure's down, right? Because Azure runs on Cosmos, right? So the point is that this is an extremely resilient data store that is going to be up there. And then sure enough, there are a lot of big companies that have put in big implementations in here of all different types of database types and so forth. But it's being trusted by a lot of major corporations. And then we talked about this, the fact that we have this turnkey, but also the ubiquitous regional presence. So sure enough, it's all over the world, right? You can see there's data centers all over the place. On the top of it, they have, there's some regions where you have to keep data in those regions. Number one, if you're DoD, right? Obviously you have to keep it in a DoD or government, right? They actually do have, they have those areas, but also, for example, China, right? If your data is in China, China has very strict controls, and they've done that. Or Germany, right? Germany actually requires data remain in their country, and you can do this with Cosmos. It's built in. Along with this, it really goes with anything in Azure. But it's secure by default and it's enterprise ready. Look, Microsoft learned from the Windows XP days, right? So if you've been around as long as I have, you'll remember when Bill Gates came out with a memo talking about how we must do everything security first, right? Talking about Microsoft has to do this first, and Microsoft has taken this very seriously, and they continue to do this. And so everything, it's extremely secure. And one of the great things about this is they've actually have gone through and they've checked pretty much any compliance standard that's out there. They've actually made gone through and checked that, right? So whether if you're in healthcare, you need HIPAA and high trust, you're good. You're doing credit cards, you have PCI in there. Some of the harder ones like Singapore has the standard. It's extremely hard to get. Microsoft has that, right? Now, grant you, it's then up to you to then keep on managing all this stuff, and because obviously it's only until Azure provides what they provide you. On top of it, when we talk about Cosmos itself, the data is encrypted at both rest and in motion, and you don't do anything for it. Matter of fact, there's no settings, right? And it's interesting. Like actually, I think this has changed, but for the longest time, Azure SQL, you actually had to specify the encryption pieces. This actually in Cosmos has never been an option. It's just there by default. And you can also do that row level authorization to get that strict security clearances. Any other really cool part about Cosmos, this is really the last piece I'll talk about Cosmos itself, but, is the fact that I can have my data in different data formats, right? Now, most everyone, when they think about Cosmos, they think that one up there in the middle, the SQL core, right? So that's a document library, I'm sorry, a document database. So your JSON documents that are stored in there, and then, you know, provides a SQL interface, query it. And actually, a SQL interface is pretty darn close to what you would do in a SQL server, right? Or Oracle or what have you. But also, I mean, they support things like Mongo, right? So you can move a Mongo database over to Cosmos, and it has full wire protocol, at least up till, I think it's version 3.6, right? And Mongo is several versions ahead of that. So, you know, so you can do that kind of stuff. Cassandra, or if you're, you know, my love, graph databases, right? You know, they have the Gremlin API, and you can, you know, you can manage all those. Now, the one restriction here is that this you can only have one data API per Cosmos account. You know, so you have that limitation, and you can't change it once you've created it. But you know, so all right, so that's Cosmos in a nutshell. So now let's talk about the change feed. You know, so what do we mean about the change feed? So basically, the change feed, like I said at the beginning, right? It's listening to Azure Cosmos Container for any changes, and then outputs that as a sorted list of documents that were changed in the order they were modified. And then these changes are persisted and can be processed asynchronously and incrementally, and the output can be distributed across one or more consumers for parallel processing, right? So, you know, so number one, if I have a lot of data coming through, I can segment it off. So, you know, maybe names, and, you know, so A through F comes, or A through M comes through here, and, you know, N through Z or what have you, you know, comes there. We can do that segmentation, right? So really nice. And sure enough, and I gotta admit, this is not my original idea. I actually read an article not too long ago that was talking about this. You know, Cosmos, you know, the change feed really is unsung hero of Azure Cosmos, right? Because this is what allows me to do all kinds of things. So some important things to note about the change feed. Number one, it is enabled by default. So it's not like I have to ever worry about turning it on. It's there, right? You know, you don't have to do anything to turn it on. You know, all you have to do is basically start using it, which is nice, right? We don't have to worry about that. So as of today, it includes inserts and update operations. So note, it does not include deletes at this point. And one of the other limitations, and I'll talk about this in a moment also, but is that you don't know if a record was inserted or updated. All I know is that a record was either inserted or updated, and I have that record as what its current value is. So that is one of the limitations. Microsoft is working on this, and of course there are workarounds. We'll see some of these workarounds. You know, like for example, I could do a soft delete. All right, so have a flag in there, and I can track it that way. There are some other workarounds, because actually Cosmos does support a time to live, and actually when I get to the demo part of this presentation, you know, we'll talk more about that. But you know, this is a work. I'll just put it this way. I have heard a little bit more. You know, I was actually talking to the Cosmos team last week about this, because I asked specifically. Actually, I asked because I thought I gave out NDA information, because I actually thought it was already in place, but it's not. And then sure enough, I was actually asking one of the Cosmos team, like, did I accidentally break NDA? He's like, no, here you go. Here's the issue that we're working off of. You know, so it is right there in GitHub. But it does look. My guess is probably first quarter of next year. You're gonna finally see that. All right. Next thing. So each change appears exactly once. So you don't have to worry about, you know, scanning through. Did I already get this? Right. You're only going to get it once, you know, when you read it, and that's something really nice to know. Next is that, you know, this might sound like a limitation, but you know, your clients actually manage that checkpointing logic. So the Cosmos itself does not manage that. But that's actually a really good thing. And because of that, I can actually have multiple things going against the same change feed, right? And we'll see that, right? I'll actually have a demo where I have 3 different things that are reading it, and they might be reading at different speeds, right? Because maybe you know, an action takes longer to take, right? We can actually read those, you know, and get that checkpointing logic, you know, set for each one. So sure enough, they are sorted by order of modification. You know, which now within a logical partition. And I forgotten if I've got another point of this, but one of the things to consider with this is that while it is sorted by order of modification, you're not guaranteed a sorting order across different partitions. So Cosmos is really keen on the partitions. Your partitions can only be no more than 20 gigabytes. That sounds like a limitation. It's actually not too bad. The big thing you have to, partitions are actually really, really important. I mean, we could do a whole presentation just on how do you set your partitions. But the one thing to note is that within the different partitions, you're not necessarily getting them in order, right? So I might write, A1, A2, A3, and then B1, B1, 2, B3. And the order I get it, if I'm watching all the partitions together, I might get like, A1, A2, B1, right? Even though, that wasn't necessarily the order it was written in. So nothing to consider in there. Okay, yeah. So here was the point I was just talking about, the no guaranteed of logical order partitions. Next is that I can synchronize from any point in time, right? So this is really nice. I don't have, there's no fixed data retention period, so number one, if I need to go all the way back, I can. And then, no, not finally, but so changes are available in parallel for logical partitions. So again, this is really nice. It's because I can actually separate the data and process it by multiple consumers. And then finally, point on the overview here is that applications can request multiple change feeds. All right, and again, we'll see that when I get to the demos. All right, as far as where it's supported, so we talked about there's a bunch of different data APIs that Cosmos supports. So as far as the change feed, it's basically supported by almost everything. So the core or the SQL, Cassandra, Mongo, and then Gremlin. The one that's not supported is Table API. I actually don't know if they have that planned. But I think part of the reason why is because the Table API, it is actually the exact same code base that you get in Azure Storage. The difference is it's just with the global scale that Cosmos provides, right? And so I think that's the primary reason why Table API does not provide a change feed. And as far as application drivers or development logic, I can do in .NET. And that's both .NET Framework or .NET Core, Java, Python, and Node.js, right? So pretty much whatever language I'm working with, I've got an SDK that'll allow me to write with that. And one quick note on here, the way how Mongo and Cassandra implements the change feed is different than the others. And the primary reason I'm bringing this up, it is actually works more within those native tools. And sure enough, I gotta admit, I do not do, I've done one Cassandra database, and that was just to say that I did a Cassandra database. And I've done very little on Mongo. So I won't be showing any demos of that, but that is something to note, is that some of the code is different, right? As a matter of fact, we'll be working on Azure Functions here in a little bit, and the Azure Functions themselves do not work on either one of these databases. They actually, currently, they only work on the SQL API. All right, so some limitations, some of which I've already talked about. So number one, the intermediate updates. So basically, the only thing you get when you query the change feed is the last update, right? So if I updated a document 5 times in the time that I read that change feed, I'm going to get that last update to that record, right? And so that's something to note, right? Because depending, how quickly I'm reading it and how quickly I'm writing it, right? I might have an issue there, right? So you definitely want to consider that. So if a record can get updated like 5 times in a second, but you're only reading it every 5 seconds, which is actually the default, then obviously you're only gonna get that last record. So that may or may not be a problem. So that you have to think about that. The next one, the guaranteed order, right? And we talked about this a moment ago. The whole idea of within a partition, it is guaranteed, but it is not guaranteed across partitions. So I could get things a little bit out of order on that way. Although again, within that partition, it is, in the individual partition is guaranteed order. And as we talked about, deletes are not supported yet. And this, like I said, this is coming, and we'll see some ways how we can get around. All right, so how do we get to the change feed? So it's not, actually it's not something I can just go look at, right? I actually do have to use some code to get into it. And sure enough, you can use the SDK. I mean, so the Cosmos SDK actually provides you the mechanisms to actually read into that change feed. But the better way is to use the change feed processor. So this is, a more higher level API that Microsoft provides that actually kind of really takes away a lot of the hard coding in there, and gets you to a more easier structure in here. And sure enough, like I said, we'll be talking about functions, because actually most everyone, that's what they're using. They're using Azure Functions to read their change feed. And the Azure Functions in the background are using the change feed processor. So it's good to understand what this is doing. So, all right, so let's talk about the components. All right, so what makes up this this processor. So the first part is the monitor container. Right, so the actual container that we're looking at, that we want to watch for changes that are happening. And then we have a leased container. Right, and so basically what this is, the leased container really is what is maintaining the checkpoints. Right, so it knows when and where, what was the last thing I read and where do I need to read next. Right, so we have that leased container. And sure enough, you'll see this, right? When we look at the databases, you'll see something called leases. And granted, you actually can name it whatever you want to, but I generally just call it leases. Next one, we have the host, right? And so this is the application that actually will listen for the changes using the change tree processor. And here we can have multiple instances with lease configurations, and so they can all run in parallel, excuse me. But each instance should have its own different instance name, something to consider. And then finally, we have the delegate, right? And this is the code that defines what you, the developer, want to do with each batch of changes, right? So this is, really, what we're talking about here is, what you're actually trying to do, right? All right, and then here, this is just a quick little chart to kind of get a better understanding of what we're talking about. On top, we have that monitor collection. And in here again, we can have this separated, partitions. We have those lease collections that are actually doing that separations, and then we have the host, right? And so the host would be the that third piece, and then the consumers are that last piece of the delegates. All right. So as far as the life cycle of this, number one, we read the change feed, right? So, the change feed processor will go in there and we'll just go read that change feed that Cosmos has under the covers. And then basically we're going, it's going to look for changes, right? If there are no changes, then it's going to go back to sleep for a predefined amount of time, and then, and go back to step one. But if there are, then it will send those changes to the delegate, right? And again, this will send it as a collection of the documents, and then that delegate can then do its work, right? It sends it off, to do whatever it needs to do, and if it returns back a successful completion, right? And so this is the good part, right? Then it will update the lease store, and that's important, right? Because so if I fail somewhere in there, right, I know that the next time it comes back, I'm gonna get that record back, right? Which is a good thing. And then obviously we go back to read the change feed and do all the process again. All right, as far as where can you host the change feed processor, number one is an Azure web job, right? So if you need that continuously running type idea, we can do this. You can do an Azure virtual machine, right? So just like you would normally think about this. We can do a background job in AKS. Well, I have misspelled Azure in there. But we can have that background job. Or the fourth option you have here is the ASP.NET hosted with service, right? So so you have these different options. But while that all sounds great, again, like I said, there's a little bit more into this, especially if you're dealing with a SQL database, which most likely this is what you're going to be dealing with in Cosmos. You can actually do serverless, and you can actually do this through Azure Functions. So let me quickly explain Azure Functions. So if there's anyone who's never done Azure Functions before, really quick what this is. And number one, I always like explaining the logo, because the logo actually kind of gives away a lot of this. So basically, you have the code, right? And you have the events and data, and they basically put those together. So kind of like that Reese's cup, the whole idea of putting peanut butter and chocolate together. Here's putting code and events and data together, right? And essentially what we're talking about is the ability to have small pieces of code, and small does not necessarily mean not complex, right? Although generally they are small because they're generally meant to be fast reacting. But and then have this out. Yes, McNerdy's, I know your love for Azure Functions. But yeah, we can, we can have these small bits of code out there running for us. Some big features of this. And number one is serverless, right? And what do we mean by this? Well, number one, I mean, if you haven't heard the whole joke, I mean, obviously there are still servers, right? But what we mean by serverless is that I'm not having to deal with the server. I don't even know what kind of server it is, right? You do define whether it's going to be a Windows or a Linux box, but other than that, you have no idea, right? And because I don't care, all right? Along with this, I also don't care about how many boxes I'm running on. It just automatically scales up for me. That's one of the real big benefits of serverless. Sure, I'm going to take those off because I really don't need those while I'm presenting. So next, language choice. So one of the awesome parts about Azure Functions is the fact that I can, pretty much whatever language I'm using, well, I mean, whatever primary language I'm using, we can use this, right? So obviously C#, right? Because I mean, that would make sense, but also Java, JavaScript, Python, and PowerShell, right? So I have a lot of options that I can use to write my code in to use this. Next, it is generally a pay-per-use model. There is actually other models, but it is generally a pay-per-use model, and generally you pay, and I don't remember the prices off the top of my head, but you pay, for execution and for execution time, right? And execution is a simple, and I'm literally forgetting the pricing off the top of my head. I'll say like, I forgot what it is, but it's so much per million transactions. And then the usage is basically how much memory usage over number of time you're using. And so this can actually be very efficient. I've done a lot of presentations on Azure Functions, and I always talk, when I do my my price comparison, we always talk about how you can have a function that's doing 3 million transactions a month, basically costing $18 a month, right? So it's very cost effective. So BYOD, bring your own dependencies, all right? So Azure Functions fully supports NuGet and NPM. So you can bring in whatever package you need. And sure enough, actually, my general recommendation when you're writing Azure Functions is actually your code should be in packages. Because the one thing that Azure Functions does not do very well of is testing, all right? So unit testing. So if I actually write my code into a package and then include those in there, then I can test those packages separately. But again, the nice part is we do have this ability. Next is security. I mean, just like anything else, within here, but especially now this doesn't affect, we're really talking about with Cosmos piece, but this is really if you're doing like HTTP trigger functions, I can do OAuth providers, right, to provide me that security. Integration, this is one of the things that Microsoft and with Azure has been amazing with, right? So I can integrate with just about with most other services in Cosmos, or I'm sorry, in Azure, right? To include like Cosmos. I mean, that's how we're getting to the point we're getting here, right? So lots of availability there. Flexible development, it fully supports continuous integration, continuous deployment. But on top of it, as you'll see, I can actually also write code and run it on my local machine, even though it's meant to be a server, a cloud-based thing, right? I can actually write my code, which means I can debug my code on my local machine. Sure enough, normally when we talk about serverless, we usually talk about stateless, and most Azure functions are stateless. But should you need a stateful operation, you actually you can use durable functions to get that. And then finally, and actually I really like this fact, it is open source, right? So you actually have full access to the code. More importantly, you have access to the issues and so forth. And actually, the Azure Function team is really good about addressing issues that get written up there. So I mean, if you are seeing problems, definitely go into their GitHub library and a repository, I should say. And, you know, and number one, first, obviously, look to see if there's already an issue, that either already resolved your issue, but then you can write and they will respond to those. All right, as far as what you can do, and I'll go over this real quickly, HTTP triggers. So, think of like REST calls. We do timers, so we can, and sort of you can mix these up, right? I mean, I could, especially if, with durable functions, I can actually mix these up quite a bit. But timers, we can trigger off a blob store, so something changes in it or is modified in blobs. Queue stores, same idea, a first in, first out. Event grid, this is, I know, one of Kevin's favorite things. You can actually write functions against there. Event hubs, this is actually one of my favorite things. Service bus queue and service bus topics. Actually, it's kind of funny because actually service bus drives event hub. And then Cosmos DB, right? What we're here to talk about tonight, right? We can do these. So sure enough, now we kind of quickly understand what Azure Functions are. I mean, here's where you see this, right? So you see data coming into your Cosmos database, a change feed, keeping track of all those changes. And then that data actually gets pushed out into the, and basically in the background, what's happening is that, there's a change feed processor that is sending this out to the delegate. The delegate just happens to be an Azure function. So this actually provides a really nice way of getting some things done. I'm just looking at my notes, and then again, the one thing to note here is at this time, the only data API in Cosmos that's supported is SQL or the core. It's actually interesting. Graph databases used to be supported. I was actually playing with that last night on stream, and it is no longer supported through there. And again, I could still write code against the change feed processor myself. For Azure Functions, you have to do this. All right. So now we've kind of gone through a lot of explanations. Let's talk about what you can do with the change feed. All right. Now we've done, we explained a lot of this. There's actually a lot of great things we can do with it. And here you can kind of see some ideas. All right. Computing and notifications, right? So the whole idea of actually sending in a notification, right? This type of model actually gets used in several AAA games, right? They'll actually will receive those events in there. They'll get written into Cosmos, and a change feed is actually monitoring that and says, "Oh, I need to notify them that they've now, I don't know, got 100 bonus points or what have you, right?" So that actually can happen here. Stream processing, right? We can actually tie the change feed into to like a Spark engine, and then do analysis on it. Or I can tie it in, and get it into Stream Analytics, and then do that real-time analysis on there. And then data movement, right? And this honestly, this bottom area, this is where you see most work done with the change feed. And we'll talk more about that, but moving data, whether that be changing it from one state to another, or literally moving it to like an archive or to another storage type thing. All right, so it's the common uses. Number one, like we were just talking about, event computing notifications. Actually, I just said all this. I just realized that the slide is kind of duplicate of what I just talked about. All right, so let's get into demos. Let's see what we can do in here. So I'm actually going to do a series of demos. So first, what we're going to do is we're going to show just actually how this works, right? So we're going to see data written to a Cosmos DB, seeing that going to the change feed. Again, you can't actually look at the change feed itself, but then we're going to write a function that will then monitor that. Okay, let's switch over here. All right. So I'm just going into Visual Studio. I'm going to create a new project. I want to start from fresh, and we're going to do Azure Functions. All right. I'm going to go in here. I now need, I need to find a name. I'm not going to worry about the name because this is just code I'm going to throw away right after we're done here. But we define our name, and then we're going to go to the page asking me what type of trigger I want to use. Now I do need, because I was fooling with this, and you go back to version 3. Version 3 is the current version. That is the version you should target. It is nice though. They still actually have, I mean, number one, if you do .NET Framework, you have to do version 1. I don't remember if Cosmos is supported by the .NET Framework. Yes, it is. I thought so. But version 3 is what came out with .NET Core 3. So generally, that's what you want to work with. All right. So in here now, number one, you see the storage emulator. So actually, this is where the Azure Functions stores its code. And so it's asking where you want to do this. And again, because we're going to do local development, we're going to have this in the storage emulator. And now I just need to give a connection string setting name. And this is up to me, right? This is the name I'm going to give in my app settings as to where to find that connection string. So I just normally call this Cosmos connection string. Then you get a database name and collection name, and I forgot what I called it. Let me look that up real quick. Okay, initial demo and demo. So we're going to say initial demo and then demo. And actually, I could change that later. This just kind of helps set it up here. So, one of the things that, that they did a really nice job with these templates is it actually really does set this up for you. Oh, thank you for opening up on the wrong screen. Okay, there we go. And this is also very normal where we'll see, a bunch of red squigglies for a moment. I don't know what it is with Azure Functions, but it does take a moment for it to get the NuGet packages read in. So that is not unusual to see red squigglies at first. And here is an Azure function, and most functions are pretty much the same, but we can see in here, right? So we see the trigger, right? In here you see the database name, the demo, the collection name that we were talking about, and along with the connection string. Now, sure enough, and then my least collections. And you'll notice I don't have, if I was to go not to settings, but into, I'm sorry. No, I'm sorry. I forgot what I was saying. You notice I don't have demo. I don't have a Lisa's collection in here right now. The nice part is I can actually go in here and I could say, well, let me type that again. Or sorry, create lease collection if not exist equals true. Now, admittedly, Aaron, because this actually drives me crazy, a little bit of OCD there. I gotta have them all lined up. But I usually recommend you don't put this in production, this create lease collection if it doesn't exist. And the reason is because, my general attitude is I want to know if for some reason that lease collection disappeared, right? So I generally want to create my collection beforehand. But, for demo purposes, this works really well. And that's the reason why you can put that in there. All right, before we get to the code, the one thing we do need to do is we need to go to our local settings. And this is exactly what it sounds like. It is local. When you deploy this Azure function, these settings do not go up there. So any settings you put in here, you do have to set within the function. But again, we call this Cosmos connection string. And we're gonna have that value. And sure enough, you can get your value. And I'm basically gonna dox myself, but I actually, as soon as we're done here, I'm deleting this this account, so I'm not that worried about it. But if I go to keys, we'll grab our key right here, and actually we want the connection string. I will say I actually had a really good conversation with the Microsoft Portal team last week, and they are, they're getting ready to work with the teams, so your keys are not shown by default, right? So they're hidden, and you have a copy button just like you do today. So there, we have our account key in there, right? Because we're going to need that here in a moment. So, and sure enough, now one thing I do like to do, they default this name to input. I like calling this documents. I just think it's a little bit more intuitive as to what I'm doing. You can see we're going to get an I read-only collection of documents, all right? Which, if we were to look at that, we can see there's a couple of properties in here, but more importantly, they add dynamics into here, right? So that's what we'll see here, and we'll see what exactly it returns here when we run it. But then we, you know, and then the other part is we'll have, so we're checking to see if documents isn't null and that count is greater than 0. And it's just doing something very simple. It's just going to do a count, and then it's going to print the ID of the first one that exists in there, right? And sure enough, for demo purposes, this works really well. So what I'm going to do is we're going to go ahead and run this. And again, this is one of the awesome parts because, you know, once this gets compiled, you know, we do get this in a console app right up here. So we you know, we can actually run this, you know, locally. Actually, one of the disappointing parts is they used to actually have the Azure function logo in ASCII art. Get rid of that, which is funny. Matt Groves over in Columbus absolutely loved every time that showed up. All right, so what I'm going to do here, I'll move this so that we can go back to our Data Explorer. We're going to do it like this so we can actually, you know, we can see when this happens, right? So I'm going to go in here. I'm going to go to my initial demo. I'm going to go to the demo item, and I'm just going to create a new item. And again, because this is NoSQL, it's not like every document even has to have the same type in, you know, or items in here, because it is just that, right? So you do have to have an ID that is required. So we'll just say 1, 2, 3, and then we'll just have, you know, we'll have user group, Hampton Roads.net user group. And let's say location, and we'll say this is Norfolk, I believe is where this is based out of. Kind of hard part because I'm sitting here in Kentucky. So we're going to create this now. I do need to put in a partition key, and I forgot what I set the partition key to, so I'm going to go over here real quick. Oh, I just set it to a partition key because this is required. If I try to save it, I will get an error. So we'll just say partition key, and we'll just give this 1, right? Whatever, right? So now, once I hit save, after maybe a second or two, you'll actually see something come up on this console app because you'll actually see it read it. So we'll click that save, and there you go. You see it, and it says executed function 1 succeeded, and you see documents modified 1, first document ID 1, 2, 3, right? Obviously, if I was quick enough to beat the change feed, I could get multiples in here. We'll see that here in a moment when we get to more automated demos. But again, one of the cool parts that we could do with here is because I can, one of the nice parts about the ability to run it locally is I can also put breakpoints in here. And I want to show what the document looks like. I'm gonna run this again. I really should have put that breakpoint in to begin with. Actually, I could have. I just remembered I could have put it in anyways. But that's okay. There, we're back running there. I'm going to wait till I get the next blue line that tells me that it's actually connected. There you go. I want that. You don't really have to wait, but I just like to wait. All right, so I'm going to go ahead and copy this. We're going to do a new item. And we're going to do 2, 3, 4. And this one will say, how about we say Louisville NET Meetup. That's the one I run here in Louisville, Kentucky. I'm just going to keep the same partition key. We're going to click save. Why? Do I have an error here? Oh, there we go. It does actually, that's pretty nice. It actually is verifying, hey, I did not have a valid JSON document. All right, now I'll click save. There it gets saved. And we see that executing. So what I want to show, just to give you an idea of what's going on here. So, if we look at this, I basically get a string of the JSON document, right? Along with the other, the values that Cosmos sticks in. The RID, the self, which is the self link, There's also a, if we actually look at this a little bit more detail, the time to live, right? So, did we set a time to live value on here? And we'll talk more about time to live here in the next demo. Timestamps and everything, right? So I can deserialize this into an object, and I can do whatever work I need to do with it, right? So that's what I wanted to show there. All right, let's switch back to the presentation for a moment. And so now let's talk about the next demo we want to do here. Whoops, there we go. So let's talk about data archival or data movement, really. We could also talk about this. Here, let me get off my, I'm actually not in the way. So in this scenario, I did take this from a proof of concept that I did for my company. Although I have I did more than denormalized data. I anonymized the data. That's the word I'm trying to say. So sure enough, you're not seeing real world data, right? It has been faked. But basically a practice test application. So here, we got, we have students that are taking practice tests on here, and sure enough, they might be doing, 428,000 records. I mean, in this demo, I'm actually processing 428,000 records a day, right? So here's the thing: it might not actually be useful to keep that for more than say 30 days, right? So but we definitely don't want to lose the data, right? Because maybe we want to do an analysis over a year or what have you, or whatever we need, right? So we can do different things with there. So in here, that's exactly what we're going to do. We're going to actually, as data is written into Cosmos, we will archive it into a blob storage. That way we can see exactly what's going on. And so sure enough, here's the scenario that we're going to go through. The application or the device, because you can also use this like an IoT situation, right? So everything's sending lots of data over to Cosmos. Again, those inserts are recorded into the change feed. We're going to have the Azure function that is going to go read that, and then we're going to write that data into cold blob storage, right? Again, switch back over to our demos. And now, here we go. There's a project I want. So, but actually I want to go back to my web browser for a second here. And what we're going to do in here, now we're going to go to this move data database. And I probably kept these a little separate just to, to signalize on what the scenario we're working on here. But in here, I was like, I have data. No, it's because I'm actually looking at the other one. So in here, you'll see I don't have any data right now. This is a clean container with nothing in here. But one of the things we're going to do in here. So in our, now in the scenario I said we would delete it after 30 days, right? But maybe we, now we're not going to, obviously we're not going to sit here on stream for 30 days waiting for that to happen. But we do want to see what's going to happen. So I'm actually going to go into settings. I'm going to turn on TTL or time to live. And I'm going to set it to 30 seconds. I grant you, that's not very realistic. I mean, that's not what you're going to really do in production. But for this purpose, it makes a lot of sense, right? Because we want to see things happen a little bit faster. So I'm going to go ahead and I'm going to save that. And we're going to wait for Cosmos to save that setting there. Well, while we're waiting there, actually, let me go ahead and get up my Azure storage. I actually just want to go to containers. So we'll create our container archive. There we go. We've got our container where we're going to actually store all this. And there we go. That setting has been set. So now if we go into the code, what we're going to see in here there we go. So we're going to see something similar to what we saw before. Now, sure enough, I've gone in here, I'm doing a constructor. I mean, this is just general good practice, right? Actually, don't create that storage account every single time I'm getting into it. It's interesting. I don't know where my collapse buttons went. There we go. That was just weird. My collapse buttons had disappeared. But in here, again, we're going to see very similar to what we saw before. Now, the one thing that we didn't see before was this lease collection prefix, right? This is what allows me to have multiple consumers going against the same lease, right? Because I'll have that prefix in there, and so that's what, so it actually will store the different checkpoints, right? We've added that in here. And again, I wouldn't do this in production. For demo purposes, I'm allowed to create that. But simply, we're going to go in here. I mean, we're going to make sure we actually receive something. I mean, you shouldn't actually, this function should never be fired without anything, but this is good error handling here. And then in here, we're just going to go through every document that came in here. We're going to call this archive method, which is simply, and this is pretty much boilerplate blob storage code here. Because we're going to deserialize it. We're going to create our blob name, which, sure enough, this is a good thing to note. Blob naming is actually really important because Azure Storage will actually use patterns for when you're looking for things. So, like for school, I know I'm going to have a lot of school, so I'm actually school-ID, right? So it's actually something good to note. In here, I'm going to get my blob, and then I'm going to convert this to bytes, and then we're going to, this way we can actually send this up as a stream. This is essentially what happens here, this upload byte array. It's basically, it converts into a stream and sends it over there. And then this last line, this is just going to, this is for demo purposes. It's just going to show that. So I just realized, I know why I didn't get what I wanted. I don't actually have the solution open up. There we go. That would have been helpful. So then just to see what, we have this demonstrator app, all it's going to do, just to show you what it's doing, it's just going to start writing data to Cosmos, right? And sure enough, it's just going through a loop. Basically, it's going to read in a CSV file that has the data, and it's just going to loop everything. And one thing, now, this delay in here, this actually has nothing to do with the change for anything. This actually, like I said, I actually did take this from a proof of concept that I did a little bit over a year ago. And what we wanted to see was actually the way how data really was being written. So it's actually like reading the next record to see, okay, when is the next record supposed to be written, right? So it's interesting. You'll see as the demo runs, you'll see that it'll slow down, speed back up, and so forth. That's actually not my computer halting, is actually doing a real simulation, which is why this takes 24 hours if I sat there through the whole thing. All right, I'm gonna make sure that we are starting the right solutions in here. We're going to go to our startup. So we are starting the Azure function, the archive function, and we're starting the demonstrator. Okay. Let this get running here. There you go. See there's my demo app, and then here is the Azure function that we're gonna be watching. Now, the one thing I do want to show real quick. So if we go back to here to the portal, if I look again, there's nothing right now in the archive, and then there's nothing in the Cosmos database, right? So now we're going to click on number one option. It's going to import those 428,000 records. Now, as I click enter, we're going to see records start writing up here. And after a brief second, they're getting written in here, right? And the cool part is, if I was to go into here, I'll see data in here now, but I will also see data in here, right? So the data is automatically getting written over there. And so the nice part is, I'm gonna go ahead, I have to hit escape. So now I've stopped writing data, and after, you'll see that this will, finish really quickly. Interesting, like when I was running this last night, it took a little bit longer to stop. But so that's all caught up. So sure enough, again, I have data in my archive, right? And I'm purposely stalling for about 30 seconds because I'm waiting for the data to clear. So but it hasn't all the way cleared. There we go. You can see it is clearing, right, as I refresh it, as those 30 seconds takes its time. There we go. And so sure enough, all the records have now been deleted from here. Now, grant you, in theory, in reality, records would have kept on being written in here, but this is showing how, I still have it over here, so I still have an archive. And what is actually cool, the way how, and I could have done this differently. I mean, I had full control over this, but I literally just wrote that JSON document, which meant if I wanted to populate into another database, another Cosmos database, I could, or another database of whatever type, because I have everything that was in Cosmos. I will say, this is kind of interesting. If I was to go to a new query, and if I select value count from C, right? You notice it actually still shows 101 records. It actually takes it a moment. I don't know, it's kind of weird. But if I query it, I can't query for anything, all right? So it's not like the records are, so if I do a, select star, they are gone, but the way how it does the counts are still there. So that's kind of interesting. Again, it has nothing to do with the change feed, but I just thought that was interesting. All right, so let's go back to our presentations. All right, so the next area we're going to talk about, and this is for denormalization, all right? So in here, the example app I've built here is what I've called the Shindig Manager. Now, sure enough, so here's the thing. I keep on working on things. You're either managing my speaking engagements or managing events, because I run events. And, the problem about the word event is that it's a keyword in like every language there is, right? And actually, last week or the week before, I guess it was the week before, we were starting something new and on the stream. And I was trying to think of a better name. I was like, let's get away from event. And actually, I was looking for synonyms, and I came up with Shindig. And so that's what I've been calling everything. So we got the Shindig Manager. It's managing different Shindigs, events, right? And then sure enough, one of the things that we're also going to see in here, the metadata is maintained its own container, right? So like the tags or maybe the speakers or what have you, right? But what we want is a way to denormalize this data, right? So the whole idea, if I change the name of a tag, right, I can see that it gets populated over here, because the thing about NoSQL databases is generally I put it, in a relational database, we normalize the data, right? So we don't store the name of the tag, we store the ID of the tag, right? And then we'll go grab that, and then that way when we do a query, we'll say we'll do a join to join that tag table, and then to get what the ID or what the name is based upon the ID. Well, in a NoSQL database, that's not what you want to do. Primarily because there are no joins, right? Sort of. Actually, there is a type of join. So I want to be, but for all intents and purposes, you can't join different containers together, right? Because that concept is not there. You will actually do denormalization on these documents. So what happens if we change the name of a tag, or let's say we're working on, on something, now all of a sudden we want to call it something different. Oh, we need something that's going to go and update all that data for us. So we'll go back into our demos. Oops. And let me just close this one so it's out of my way. All right. So now, instead of the archive data, we're going to look at this denormalized data on here. So in here, and it's going to be a lot of the same thing, right? So you can see now I'm going to be looking at this metadata collection, and we're going to, in here, we're going to process this change. Now, sure enough, in here, so the metadata I have is topic, tag, and speakers, right? So in this way, we can, so if we name, we change the name of a topic, we're changing the name of a tag, right? Or speaker, right? So the speaker name is, wrong, right? We can get this propagated across everything. And you can see, and the reason why this is important is So like on speaker, I did something a little bit different, right? And this is kind of showing more realistic what would happen, right? So, and here I'm calling them a little bit differently, right? And so in here, you can see in my update, I'm actually looking, I'm gonna look, in my target collection, give me all the presentations where, actually up here, I'm sorry. I'm gonna first get the presentations update, right? This is the bad part. I have to actually do this multi-step, it is what it is. But so the first thing I'm gonna do is, for like a tag, give me all the presentations, give me the identifiers of all the presentations that have that tag. And then up here, this is where, we'll then select those, right? And we're gonna do them individually. And then I'm gonna do the update, the necessary update to do this, right? And it really, it's the same thing for speakers, but obviously we're handling a little bit different because we have, a first name, last name, and so forth. All right. All right. So now I'm gonna go ahead. I'm gonna run this. I think. There we go. Oh, I forgot to change the startup objects. Sorry, just 1 second. Go to set up startup projects. And instead of the archive, we're going to start the denormalize function. All right. Once again, we'll have this function. We'll see, you'll see the transactions happening as we go through here. And then we have our demonstrator app. So I'm now going to go to denormalizing data. And actually, the first thing I'm going to do is I do need to upload metadata. I should have done this prior, but this only takes a second. So let's get all this metadata. So it's writing all the tags, the topics, and speakers. And notice it is calling. The function is actually happening, right? Because it's running and it's there. It's not doing anything, right? Because there are no tags in there. Either that or I've done something wrong here. Hold on a second. I do think I screwed something up. Let's check something real quick. Go to Shindig Manager. Don't remember if it actually finished all that. Shouldn't actually be anything in here. Oh, okay. I guess I already had that in here. Okay, that's the reason why I started doing all that, and because I was writing every single thing. All right, let's do this. I kind of messed it up a little bit. Okay, let's actually just delete this whole thing. Hold on, I gotta remember. I gotta grab some notes here real quick. So apparently I didn't clean this up after the last time I practiced this. We're just gonna delete this whole database. Just a second here. This takes a moment to delete this. All right. And then we're going to go in here. We're going to create a new one. It's going to be Shindig Manager. The container we're going to create first is metadata, and its partition key is type. All right, it takes a moment for it to create the database itself. I need that Jeopardy music playing in the background there. All right, so there we've got the metadata collection. Now we're our container, create our other container from the presentations. And this is going to be event ID. And actually remind me, I just realized I'm actually doing the wrong demo first anyways. but that's okay. So then we're going to do presentations by tag. And this one will be tag ID. I realized I did the demos in the wrong order. I was doing the denormalization. That's actually talking about replicate data. So in this idea, and I apologize for this. So we have presentations, right? And you noticed, we had that partition key of event ID, right? Well, what if I want to search across all the events, right? So maybe these are all my events. I want to search across all the events, but I want to search it by tag, right? Well, the problem is going across multiple partitions is actually costly because it's now allowing Cosmos to do what it does best, right? So what we can do is, we can, so we can have like this presentation by tag container. Now, sure enough, you wouldn't want to do this in a heavy write application because, I mean, you're going to be doing a whole lot of even more writes. But when you do a heavy read, type of application, this makes a whole lot of sense. So, so sure enough, and again, I apologize, I showed the wrong demo. But if we go over to our replicate data function, in here we can see, this is where it's going to go in here and it's going to actually build the list of objects that is coming in. Build those as a presentation by tag. So basically do that conversion because there's a little bit of difference between these. Basically, the way how I added a tag ID and tag name, so because that's obviously what we're going to want in here. Again, denormalizing at the same time. And then you can see we're going to upsert those. We're going to handle upserts. We're going to handle deleted tags. This was kind of the fun part. As I was writing this, I'm like, I realized this was actually a little more than I originally was anticipating with this. But again, we're just seeing where we're writing stuff in here, right? Along with some extra code in here. And sure enough, all of this is up on GitHub. So you'll be able to view all this code afterwards. And I'll show you that GitHub in a little bit. So now, let's actually just go in here, just run the demonstrator real quick. No, that's right. I do want to run multiples. Sorry. I'm going to go back to set my startups. So instead of running the denormalizer, I want to run the replicate data. Okay, now we'll run this. Again, there's our function that will handle the replication of data. I'm now going to go back to. Okay, that's right. That's fine. I'm going to go back to my denormalized data because that's where I happen to have it. And in here, we're going to go in here and we're going to upload that metadata just to get that in there. Give this a couple seconds to write all these records. Again, you can see how quickly Cosmos is going. And again, this is my local machine writing out to Cosmos. So that's actually taking more of the time than anything else. There we go. We've written all those. Now I'm going to start writing these presentations. And what you're going to see is it's going to be generating data into that presentation container, but it's also the function will then be writing out to the tags. All right. So again, we'll go in here. We'll upload the presentations, and there you go. You'll start seeing this fired off, and you even see 2 documents, 3 documents, right? Because a session could have multiple tags, right? They can be tagged in multiple ways. So we can see this happening. Sure enough, that takes a moment because it's actually doing quite a bit of work in there. But if we go over here, keep that on my side so I know when it's actually done. Now if we look at the items, again, we can see, so we can see 1295, right? And we can see that, it has its tags, right? But look, it has 2 tags. It has tag 20 and it has tag 23, right? So that's great. So now what I want to look at, and there it is, the function's done. So it's actually caught up everything. But if I was to look at presentations by tag, I can now see, look, 1295 has tag 20, right, soft skills, along with tag 23, other, right? So, it just provides me another way to search for this data, right? Because maybe, I could have multiple ways to query my data, right? So that's pretty darn cool. All right, so now moving on to the next demo, the denormalization one. And this time I'm going to run just the function itself. Okay, so we're going to run this. And it's going to start. And again, this is the one. Now, this is watching for changes in that metadata, right? So a prime example is, if I go in here, if I look at my metadata, we have a whole bunch, and I'm going to look. I want to see. Let me actually close all these other tabs in my way. So prime example. Let me see here. I got to find the ID for it. New query here. Select star where c.name equals soft skills. So here's the thing. For years, I've had this tag for like Code PaLOusa of soft skills. The thing is, soft skills is a little bit misleading because soft skills makes it sound easy, right? Or actually, we talking about this on my stream the other night, or makes it sound like it's not a man thing, right? Because it's soft. It's really a better title for this is people skills, right? Because that's really what we're talking about. This is what I was looking for, is that tag 20. That's what I wanted to see. Now, if I go to the items for this, and if I find tag 20, so what I'm going to do is we're going to make that change. We're going to say people skills, right? And then, so here's that. It's going to watch for that. And if we go in here, and if we save this change, again, we're going to see that this trigger, there we go. So there it's going to start denormalizing the data. And you can see it's now going through all those documents that got changed. And sure enough, I actually should have been running the replicate data also, because what it didn't do is update the other container. But if I had that running also, actually, if I start it now, it'll catch that up. But to replicate that. So now, sure enough, if we look up, if we go to our presentations and do a query on here, say where see, that's here, because we can actually search for something here. That name. So where C name equals time management. If we execute this, get an error. Oh, there we go. So, and it doesn't come up. Why didn't I? Oh, let's see here. C name. Items. Title. There we go. And sure enough, now you look in here under the tags that got updated to people skills, right? So, again, just managing data as data changes, right? And allowing for denormalization to continue in a good manner. All right, so now let's go back to our presentation deck. So I have one more demo to show. And sure enough, let's see here. So there was a demo we already showed. All right, so triggering an event-driven architecture, right? So here I'm gonna do like a store, implementation, right? And here you can see like fulfillment, inventory, and notification. Sure enough, my Azure functions aren't really doing anything. They're just, actually, they are updating the record. Other than that, they're not really doing anything, all right? And really, really not a whole lot to show in here. Let me go back to my work screen. Here we go. Stop all this. So sure enough, if I was to look at one of these functions, at the actual code, not the project file, you can see all I'm going in here is, we're going to, again, look for all those documents, and then we're just going to, like, this is going to kick off the fulfillment process, whatever that would be for this. I mean, basically, this is your microservices. They're implementing event-driven architecture. Okay. So in this example, what we're going to do, now we're going to, again, reset up my startup projects. So this time we're going to not start that one. We're going to start these three here, along with the demonstrator. And we'll get this to run. Now we're actually going to get 4 console windows up here. I like how one shows up over here and the other 3 are on the other monitor. So in here, we can see these 4 functions that have got started up. They are now reading that change feed. They're waiting for changes to happen, right? And so the nice part is the application, the cart doesn't need to know that these functions need to fire. All it needs to know is I need to save an order, all right? And then, by that, we're going to do something. So I'm now going to go into this event-driven architecture. Oh, yeah. Well, that's interesting. Hold just a second. I promise this was working. Demonstrator. I don't have code in there. Weird. All right. We'll just do a wait event-driven architecture demo. Execute Cosmos. All right. The fun part about doing live code. All right. So here now again, so we have these 3 functions that are running. They're ready for orders to come in. I'm gonna go in here. I'm now gonna click for real-time event. So generate a bunch of fake names. And now you can see it's saving those orders and you see those triggers happening, right? And that's basically what I just want to show. Just the fact that I can, the real thing we're showing here is, and really what I've done is put some delays in here so they don't operate the same amount of time, although you see some of that happening. The fact is I have 3 different things watching the same container, waiting for changes to come up, all right? So really, I think the cool part, here, let me stop this just so I don't keep on sending lots of data across my pipelines. So I think really the interesting part with this, what we're really seeing here is, the limitation of the change feed is your imagination, right? You can do all kinds of stuff in here. So to wrap this up, I mean, again, we talked about Azure Cosmos DB, how it's this globally distributed, massive, scalable, multi-model or database service. Oh, sorry. Okay. And then we talked about the change feed, right? So how this is the unsung hero of the Cosmos DB. It's enabled by default, includes insert and update operations. It's sorted by order of modifications. It's synchronized from any point in time. Changes available in parallel for logical partitions. We saw that we were doing parallel operations on there, and applications request multiple change feeds. All right. Again, it's the SQL API or the core APIs, Cassandra, Mongo, and Gremlin. So basically everything but table API. I'm actually also technically etcd. etcd is not meant for a change feed anyways. And again, I can write code in .NET, Java, Python, or Node.js. The current limitations, number one, the intermediate update. So I only get that last update. So, again, if I set a change feed processor to only read a record every 30 seconds, but was written 5 times, and I'm only going to get that last right. So you need to be aware of that. Guaranteed order. So again, it is guaranteed to be in order within a partition, but not necessarily in the order across multiple partitions. And then deletes are not in there. But we saw we can do like TTL and that type of stuff. And then there are 3 processes for reading the change feed. We can do it directly for the SDK. We can use the change feed processor, which you should ignore the SDK, go straight to the change feed processor. Or if you're dealing with a SQL API, you can deal with Azure Functions and get a lot of the plumbing work taken care of for you. We talked about the common patterns such as like event computing, notifications, real-time stream processing, data movement, and event sourcing. And then finally, we saw some demos of this in work. All right. So with that, I really do appreciate you joining us for the past hour or so, and for the demos. And sure enough, any questions? Because I didn't see any come through while I was presenting.
Yeah, chat's been pretty quiet.
Yeah. So either I just wowed everyone greatly, or I just really confused everybody.
We'll say it's the first one.
Yeah. I will say just to give everyone. Oh, okay. So everything is in GitHub. I do need to check in a couple things, which as soon as I'm done here, I'll check those in. But on GitHub, if you search for Learn Code, Learn Code, and it's under the changes repository. So everything is here, including my presentation. All right. So if you want to see those code examples, they're all there.
Good times. All right. Yep. So much to absorb.
Yeah.
All right, folks. Well, now is your last chance. Drop those questions in the chat if you want to. Yeah, it's kind of weird. The chat is usually not that quiet for the entire, basically for the entire thing. So,
well, this is one of the hard parts about presenting virtually, right? Because you can't see everybody.
Yeah.
So admittedly, as a presenter, it's hard because if I actually have people in front of me, I can see like if what I'm saying is not coming across, or everyone's either nod or head or like the WTF. What are you talking about, right?
Yep. All righty. Well, we'll go ahead and cut it off there because I know, Chad, you have another talk you're doing in a couple of hours.
Yeah, and a whole different continent too.
So we want you to rest your voice and get a little bit of rest before that. But thank you everyone on Twitch for hanging out with us today. We'll see you back next month. I'm not prepared. Who is our
next
speaker
month?
Next month
Is Sydney Andrews talking about .NET documentation examples, focusing on .NET Interactive, Visual Studio Code native notebooks, and C#9 top-level programs.
Gotcha. Yeah, if you have not checked out C# top-level programs, they're so cool. It's basically just start coding without namespaces and classes and all that good stuff. And Chad, I just see you jumped in the chat. So yeah, Cosmos is Azure only. It's part of the catalog of all good things you get in Azure. So go for Sean. Thanks for hanging out with us. Couldn't hear any of it, but I'm sure he was great. Well, obviously. All righty. Well, Chad, thank you again for hanging out with us this evening. And we'll have to have you back sometime because I don't think we're going to be in person for a while.
Yeah.
And, take care, everyone. We'll see you all next month.
See y'all.